All right, so the discriminant is a part of the quadratic formula. The discriminant's job is simply to tell me the number and type of solutions. So the job of the discriminant is to tell you the number and type of solutions. So when we did solving by factoring, or when we did solving by graphing, there are only 3 cases for solutions for a quadratic. 2 reals, 1 real at 0, and 2 imaginaries. That is still true with the discriminant. So we're either going to have 2 reals, 1 real, or 2 imaginary. So the quadratic formula comes from the standard form of a quadratic equation. We're going to plug in negative p plus or minus square root of p squared minus 4ac all over 2a. Tomorrow we're learning the quadratic formula. You don't have to worry about it right now. Just kind of showing you what it is. Today we are focusing on the discriminant. The discriminant is a part of the quadratic formula. It is this part right here underneath the radical. And the reason that we focus on that, and the reason we focus on square roots, not right before this, is so that you understand how to simplify them and whether a square root is positive, negative, or 0. So if you think about the ideas, if a square root is positive, then you have 2 real roots. I knew I was going to do that. So again, the discriminant is b squared minus 4ac. It's the part under the radical in the quadratic formula. And again, the entire purpose of it is to tell me the number and type of solution. So as I was getting into, if a discriminant is positive, then we have 2 real roots. If a discriminant is 0, then we have 1 real root. And if a discriminant is negative, then we have 2 imaginary roots. Keep trying. What I have. So in example 1, you have a quadratic in standard form. It is set equal to 0. So if you want to find the value of the discriminant, you're going to take that b squared This is not a board thing. This is my laptop thing. Yep. We're going to take b squared minus 4ac and plug in the numbers from this equation. So in this case, b is negative 2. So negative 2 squared is 4. Minus 4, a is 1. That is the value on the x squared. And c is the number that stands alone. So it is 4. So you have 4 minus 4 times 4, or 4 minus 16. So 4 minus 16 is negative 12. A negative 12 tells me that I have 2 imaginary solutions. It's just not right. Yes. No. Not for these ones. I did. And it worked beautifully this morning. So it's just the connection sometimes with the computer and the board.
What is that?
Amazon. It rates 100 times better than the one they gave us.
Yeah.
Two imaginaries. I don't understand computer. Why?
Whatever happened to getting better Wi-Fi?
Yes. Because when we plug this into the quadratic formula itself is negative b plus or minus the square root. So the discriminant is what's under the square root. So the reason you get 2 is because whatever is under the square root in the quadratic formula is both going to be added and subtracted from that answer. And what we'll talk about tomorrow is like the parts of the quadratic formula and what they represent. So here we have 3x squared plus 5x equals 1. So you asked about like the equaling 0. The equals 0 only matters in the first step because you need your ax squared plus bx plus c to equal 0. So your signs on a, b, and c are the right signs. So we have 3x squared plus 5x minus 1 equals 0. I don't know if there's just like too much open. I know, I wondered if that was what was slowing down.
I wonder if you put like your computer on a hotspot.
I'm not wasting my hotspot. Okay, so you have 3x squared plus 5x minus 1 equals 0. I just think it had too many tabs, like the computer can't think. Negative b is 5. In our formula, we need 5 squared, so we have b squared minus 4ac. So you have 25. A negative times a negative is a positive. 4 times 3 is 12. So 25 plus 12 gives us a 37. So 37 is not a perfect square, but it is positive. Therefore, I have 2 real roots. So all I care about is the value from the discriminant and what it means. Set it equal to 0. Find b squared minus 4ac. So you end up with 100 minus 100. If the value of the discriminant is 0, we only have one real root. And the reason for that is because if you were to plug 0 in here, you get the square root of 0, which is 0, and negative b plus 0 and negative b minus 0 are going to be the same number. So that's why if you get a discriminant of 0, it's only one real root. So the discriminant describes the number of x-intercepts. Remember, solutions, x-intercepts, zeros, they're all the same. So when we talk about the discriminant, we are really also talking about the x-intercepts. So you can find the number of x-intercepts by finding the discriminant. So it's b squared minus 4ac so we get a positive discriminant of 24. That tells me that this graph has two real roots. It also tells me that this function is not factorable. So if my discriminant is a perfect square, then that quadratic was factorable. If my discriminant is any number other than a perfect square, it's non-factorable. So this graph has a y-intercept of 3. It has an x equals negative b divided by 2a. So it is symmetric about the line x equals negative 3. So that means this graph goes through 0, 3, and it also goes through negative 6, 3, which means the roots are somewhere between 0 and negative 6. And we will learn how to find them later. Oh, good call me. So that goes back to like our roots between and our graphing. So it does sort of all come back together. But do we kind of vaguely remember that?
How did you graph that? I got lost in the way.
So y-intercept came from the c value.
Yeah.
The axis of symmetry comes from negative b divided by 2a. The value of the discriminant that told me this graph was going to cross twice and that they were going to be non-integers. So the roots or solutions are when it's between in our table. And that's because 24 is not a perfect square. If 24 was a perfect square, then it would be factorable and the roots would be integers. Okay, x squared plus 6x plus 10. So once again, same idea. Find your discriminant. So we get 36 minus 40, which is negative 4. That value is negative. Therefore, I have two imaginary solutions, which means this graph does not cross the x-axis. So its axis of symmetry is negative 6 divided by 2a. So it's still symmetric through negative 3. But now my y-intercept is positive 10, which means it also goes through negative 6, 10. And it just means that my vertex is above the x-axis. You don't have to actually find where it is. Just know that it's above. And that's because this gives a negative, making the roots imaginary, meaning it does not cross. Okay? B squared minus 4ac So if I get 0, I get 1 real root. What does that tell me? Yep.
Vertex is on the x-axis.
Yeah, the vertex is on the x-axis and it is my only solution. And in this case, how does x squared plus 9x plus 6x plus 9 factor? Yep. So again, you can see that idea of the repeated root at x equals -3, which is actually ironically also my axis of symmetry. So you have your y-intercept at positive 9, your other point at -6, positive 9, oops, sorry, board issues, and your only root at -3. I don't make you graph in your homework tonight. Just getting back to it because we do go back to it in 5-7.
So, like the two other ones.
Correct. Yeah, it was just to give you an idea of what these graphs would look like and what the discriminant represents in terms of them. So your homework is on next page in your packets. Tell me number, type of solution, and value. Just follow the directions. Sometimes I just ask you for the value. Sometimes I ask you to describe the value. Don't do more work than you have to.